Anything else? Going once, going twice. All right. So let's welcome Ben Straub.
Hi, I'm Ben.
You don't look like a picture.
No?
It looks like the same shirt, actually.
It's pretty close. Not very creative. I've done a lot of things in my career. I've worked on device drivers. I've worked on desktop applications. I also helped write a book on Git. But today, I want to talk about automation, specifically cultural automation, which I think is a term I made up when I was writing this talk. And what I mean by cultural automation is the use of machines to assist with social interactions. It's like an overly broad, overly general way of saying something that we've all done before. Everybody's done this. Everyone in this room has responded to a text message with an emoji or a photo. And this is what I mean by cultural automation. These are tools that give us something new we can do, but not only is it new, but it also affords adding human meaning to a conversation. I've known some people that are really, really good at this. One person I know took some time off from work between jobs, and when he came back and got a new gig and he showed up in a chat room, people asked him, "What did you do with your months off?" And he replied, "Only with a photo. Nope, nothing else. No words, no nothing." But he conveyed way more with a single image than he could have by spending all day typing into that chat room. Now, I'm old enough to remember thinking that it was a really stupid idea to add a camera to a cell phone. But in hindsight, it seems obvious that communicating with things that are not text, things that are not voice, it seems obvious that that is a good idea. And as engineers and developers, we have this bias. We usually take it for granted that automation is a good thing. And with a few exceptions, that is borne out. The world is much different and probably much better, I guess, depending on who you ask, than it was 10 years ago. And a lot of that is because of increased automation and more widely available automation. It lets us move faster than we could normally. It lets us make fewer mistakes. But we also need to keep in mind that computers don't really think, at least not the way that we do. They only do what we tell them to, and only in the most pedantic way possible. We've learned from 50 years of writing computer programs and a couple thousand years of making machines in general that you got to be careful where you point these things. So when we talk about automating culture, we got to make sure that we're paying attention to the outcomes, that we're learning our lessons, that we're being careful with where we point these things. And I've got a few examples to share with you and hopefully will provoke some thought. So I used to work at GitHub, and I learned a lot there about how to be on a remote team. Some of the most memorable lessons I've got from that company are how to do workflows socially as part of software development. Automation at GitHub has a personality. His name is Hubot. It's a robot that lives in the chat room. And it's the conduit for everything that you can do with the automation that GitHub has as a company. This is the primary user interface for the GitHub machine, as it were. One example is deployment. The GitHub.com team deploys something upwards of 200 times a week. And this is the primary UI for making a deployment. You just tell Hubot to go do it. This has a number of benefits. Obviously, it's easy to see when someone is doing a deployment. It's right there in the chat room in front of everybody. But there's a bunch of little design tweaks that make this really, really nice. Everyone on the team sees deploys happen, of course. But when a deploy goes badly, you don't have to run and go get the team. You don't have to go find somebody to help you. They already know. It happened right in front of them. But maybe most subtly, this helps a lot with onboarding. Because not only do you see this happen 10 times a day, you see it happen 10 times on your first day. Your first day, you want to push out a small change. You want to add yourself to the team page. That normal rite of passage when you start at any new company. You've already seen 10 people do this right in front of you, along with the stuff that happens right before that and right after that to make sure that it worked, make sure everything's ready. It's kind of like pairing with the most experienced people on the team all the time. Another great example is metrics. The primary interface for the Graphite instance at GitHub is through the chat room. doing this is a really natural sort of activity. I'm sure we've all looked at graphs on a web page from time to time, but doing it out in the open, doing it socially adds this extra aspect to it. When you put up a graph in the chat room, you're not just saying, you're not just looking at it, you're saying, everybody, look at this. This is important. I have something I want to show you. It's like putting something up on the main screen. Once again, this has the benefit, everyone can see what the most experienced engineer does all day long. How did they diagnose a problem? How did they find the problem in the first place? What steps did they take after that? How did they narrow it down? All of that happens right in front of you all the time. Jesse Newland, who was, I think, the first ops person at GitHub, he coined the term chat ops to describe this sort of activity. All of the ops-related stuff, putting it in the chat room for everyone to look at. We talked about a few benefits here, but there are some drawbacks to this approach as well. The most obvious one is noise. When your whole product team is maybe 5 or 10 engineers, this is pretty manageable, right? You see things go by, you can kind of understand and grok every single one of them. When your team is more like 50 engineers, it's almost unbearable. You're probably deploying and monitoring 10 or so projects independently. So you move some of them into separate rooms to manage the noise, and now you don't get a lot of those benefits of everything happening in front of everyone all the time, and pretty soon your Slack looks like this. And then you have the problem of figuring out which one of these unread notifications actually matters to you. You have to triage your chat, right? It gets to be a mess really fast. And you can manage this with rooms that are specifically for doing chat ops in, but again, you're losing a lot of the benefits that way. So this has sort of like a limit in scale, and you have to figure out how to do that as you get bigger. Another example is one of my favorite punching bags when it comes to automation. When I get an HBD in my Facebook feed, my first thought is, all right, you cared enough to fill in the box when Facebook told you to. Thanks. Now, I actually remember a time when you could just click a button and Facebook would send the HBD for you, right? You wouldn't even have to type anything. Contrast this to getting a birthday card. Someone had to go to the store. They had to look through the aisle. They had to pick the right card. They had to pay real money for it. Bring it home, write a message in it, lick that disgusting envelope glue, spend more money on a stamp, take it to another place to send it to you, and plan all of this in advance so that it would get to you on your actual birthday. Like care and thought and time, effort goes into this, and it's a very human sort of a thing. Or maybe they even actually made a card for you. Like, how cool is that? So this is a case where automation hurts. When birthday cards work, it's not because of the card, it's not because you got something, it's because it's an emblem for the thoughtfulness and care and effort of the person who is giving it to you. Letting a machine do all of that sucks all of the meaning out of it. But it still hurts my feelings when I get only 3 happy birthdays on Facebook. Here's another example. This one is not mine. I ran across this blog post by a guy named Jason Hutchison. His team has a funny habit of taking one of their teammates' faces and pasting it on just random photos of the internet. Here he is meeting the President of the United States and sharing a nice plate of nachos with him. Jason, this is Chris, not Jason. Jason is another person on the team. So Jason decided that it would be possible to train a robot to do all of the grunt work here. Using a facial recognition library, he wrote a bot for his Slack instance. It's called ChrisBot. And whenever you paste an image in a certain channel, it takes that and it pastes Chris's face right on top of it. And it has a lot of really nice touches, like it layers the faces in the right order so that the ones in the back stay in the back and the ones in the front stay in the front. It does a pretty decent job of doing this. And then if it can't find a face, it still tries to do something sort of entertaining. Really, really nicely written bot. This is a great joke. It's a great prank. Now, as you can imagine, the day Jason introduced this to his team, all productivity was out the window. The whole day was swallowed with people trying this thing out, looking for its weaknesses. And I'm guessing that it was a lot of fun. Now, Jason does not go into, in his blog post, he does not go into what happened afterwards, but I have some guesses. I have some predictions as to what happened. ChrisBot was successful in removing all the drudgery from photoshopping Chris's face onto a photo, but it also removed the humanity. It took out the care and the taste that goes into making a great joke. When a new Chrisified photo comes through now, we're not laughing at the cleverness of the person who made it. We're laughing at the absurdity of a robot clumsily making a joke. We're not just laughing with Chrisbot, we're laughing at Chrisbot. It's a very, very different, it's a subtly different sort of scenario. So every one of these tools that I've talked about so far has a before and after story. The fact that they exist means that they've changed the human culture around them, like a big stone in a river. Some of the ways the river changes are predictable and intentional, but most of them aren't. Most of them are just emergent after the fact sorts of things. But can we be deliberate? Can we decide ahead of time how we're going to change culture? Can we design that into the thing as we're making it? It's usually impossible to predict the exact response you'll get from any kind of automation, but you can sometimes figure out the first response. So here's another blog post that I'll point you to. One of the coworkers of mine at Zendesk, I work at Zendesk now, by the way. I don't know if I mentioned that or not. They pointed me to this blog post from 18F, which is the organization in the US government, which is responsible for modernizing web services and applications that are delivered by the US government. They're doing great work over there. Now, the idea was to nudge people away from using the word guys when referring to specifically a group that includes women. Now, I'm not sure how it is with all of your teams, but in my team at least, and in the US in general, as far as I can tell, the word guys is a term you use to refer to a group of men, right? Going out with the guys. It's guys' night out. So when you use that word in a context that includes, when you're addressing a group that includes women, it makes them feel like they're not noticed or like they're just one of the guys. And neither of those really feels good. So they're trying to nudge people away from using that word. The 18F team used a pretty simple hack. This is something you can do with Slack out of the box. You program Slackbot's autoresponder, which is just set up in the team settings. And every time you would use the word guys, it would immediately and publicly respond to you right where you said it. So I like this idea. I like the concept behind it. But I thought Slackbot sounded kind of snotty and passive-aggressive. You wouldn't be happy if a human talked to you like this. So we wanted to be a little bit more tactful. And since we have a chatbot that we wrote ourselves, we get a bit more control over how it responds. So here's what we came up with. Our Slackbot will take you aside and have a private conversation with you. And it will gently explain what the problem is with the word guys. And it will give you a couple of alternatives, a couple of ideas of something else to use instead. Now, the response for this was kind of interesting. We had a lot of people say, whoa, that just happened to me, that's really cool, I had no idea. I immediately get the idea, and I'm just going to try to retire that word from my vocabulary. I did have some conversations with men who thought it was annoying, and they'd say, well, when I use that word, I use it in a gender-neutral way, which is exactly the sort of thing we were trying to push against, because not everyone hears it that way. But the most interesting response I got was from our office in Melbourne, in Australia. They got super annoyed with this, but as it turns out, in Australia, men and women, like everyone, uses the word guys in a gender-neutral way. It's actually a gender-neutral term in that country. But because this plugin exists, they had a conversation as a team and actively retired other terms from their vocabulary. They decided, we're going to keep guys, but these other three words, let's try to avoid those. So that is way beyond any kind of success that I could have expected from this. That was the most amazing response I've ever had from anything from any code that I've written, to be honest, right? Yeah, man, I was really thrilled when they told me. So I also used to work at a company called Gridium, and we also had a Hubot there, and we automated quite a few things. But probably the most interesting one that we automated was the high five. Now, a real-life high five is a pretty simple thing. It's two people clapping cooperatively. There's not a lot to it. It's a very impulsive sort of a thing. It's in the moment you decide this person deserves a congratulations or a thank you, and you just do it, and then it's over. And there's not a lot of don't know, there's not a lot of stuff to it, right? And so we decided to make this more awesome using automation. Automation can't really hurt this. There's not a lot of thoughtfulness or effort behind this, but automation can help it. So let me show you an example, and we'll walk through how this works. So Greg is the chief mathematician at Gridium, and he wrote the statistical model that's behind their energy management product. Patrick is on the sales team, and he needs to know how the math works in order to convince potential customers that this thing's actually worth their money. Greg is a fabulous teacher, and he regularly held sessions for the sales team to tell them how this stuff works and help them out with their jobs. And so Patrick wanted to say thanks. And so he types this into Slack, and this is what happens. So Gridium's Hubot, whose name is Gort, does three interesting things here. The first one is that he drops a GIF into the channel, and it's GIF. I don't care what you say, it's GIF. And he's got a collection of these he just draws from randomly. The second thing is that he mentions channel, which means that this is a public, it's sort of a loud, like two hands slapping, right? Everybody gets their phone blings when this happens. If they're in the channel, they get a little notification sliding in from the corner. Everybody's supposed to know that this is going to happen. And the third thing you can see on this last line here is that Gort used the company credit card to buy a $75 gift card to Amazon and send it to Greg. Now, obviously, this took some buy-in from the rest of the company. This was actually one of the founders' ideas. And so it had cultural buy-in from that. There's political capital behind it. Now, Patrick could have done all of this himself. It would have taken him maybe 5 minutes, right? Not that much time. But this took 10 seconds. It's a momentary impulse that makes someone feel appreciated. It's a high five. And much like in real life, it's sort of like they slapped hands, but instead of it just being two people clapping, like rainbow sparks emanated from the point where their hands met, and heavenly music descended. And then Greg turned around and he found $75 in his back pocket. It's the high five elevated. It's just better because of automation. So I want to show you a couple of good examples of how this emerged into use. This is about 2 weeks before the birth of David's first child, and he tried to land a dad joke, and it didn't go so well. But he's learning. He's getting better. I sent this one when our other founder discovered that you couldn't send a high five gift card for a fractional dollar amount. It was whole dollars only. I'm pretty sure it sent $3.14, but I never actually found out for sure. So we shipped this to the whole company all at once at an all-hands retreat. There was like 15 people at the time, and it was immediately beloved. There was a spike of activity due to the novelty, but then things sort of settled down into a regular rhythm. It seemed like maybe 3 or 4 times a week someone would give someone a high five. It was pretty good. The average gift card size here is about $24. The average person in the company got about $25 over that period of 6 months. Worked out really well. So in terms of a product launch, that's a success. In terms of how we wanted to nudge the company culture, it was an even bigger success. People started thanking each other for things that they probably wouldn't have done so publicly before. And as any HR professional will tell you, accolades from your peers are worth more to people in terms of being happy than almost anything else you can give them. Like, it has better effects even than like a raise of money, right? You can throw a bag of money at them, or you can have one of their peers say, hey, I really like that thing that you did. And the second one has way more lasting happiness than the first one does. The way that it was designed made the giver and the receiver both feel pretty good about this, and the bystanders too. So it was a really positive change. We even saw some emergent behavior, like there was the habit of sharing what you were going to do with the money. This is one of the founders decided to get these peelers. And I have these peelers, and I can say they're very nice peelers. There was also, because of this, there was gentle social pressure to treat yourself instead of just order more cat food. And of course, this led to more emergent behavior around that specific convention. People issuing challenges and whatnot. So culturally speaking, there weren't a lot of downsides. I mean, obviously we spent some of the company's money, but they had planned on that. The only sort of social downside I can think of is that some people got anxiety about choosing a dollar amount. Like you want to say thank you to somebody, but now you have to decide how much to say thank you. How many dollars is this thank you worth? Another one, and there's not a real good way to quantify this, is the increased number of interruptions. This seemed to be self-limiting though, right? Everyone knew that it was going to mention the whole channel, and so they would take that into account when they decided to do this. They would choose an appropriate channel in which to do it that only involves the people that maybe know this person or that were there for the thing happening. And it also helped that everyone in the company at one time or another played all of the roles in this system, right? Everyone was a giver and a receiver and a bystander. And so they knew how all of those roles worked and how it felt when the thing happened. So making a thing automated, making a tool for your team to use socially, affects the culture around it. And with a little care, we can be deliberate about how that culture changes. But a thing to know is that the fact that a thing is automated sends a signal to the people using it. The first thing it says is that we're going to be doing this thing more than once, or at least a very similar thing following a similar pattern. We're going to be doing this thing a lot. The second thing it says is that we want to take human error out of the equation as much as we can. It also says that we, specifically to cultural automation, we want just more than just one person to see this thing happening, right? We want the team or the whole company to know that this thing is happening. And then as we talked about with Facebook, we don't care how personal this thing is done. I think this is a mass market thing. This is not a handcrafted thing. So this one is especially important when the target of the automation is a person and not just a computer. The biggest thing I want you to take away from this talk is that you can do this too. The first step in this process is to get your team into some chat software. Even if you're all working in the same room, this has a lot of benefits. There are lots of them. My favorite one is that it is the first step to enabling remote work, which is a big deal. This is from the Stack Overflow. I don't know if you can read this. This is the Stack Overflow survey earlier this year. And it turns out that number 2 on the list of things that matter to engineers specifically, or Stack Overflow survey respondents, is the ability to work remotely, right? Above all of these other things, a retirement plan, long-term leave, having a private office, health benefits. People want to be able to work remotely. And it's not just programmers either. Like people in all lines of work are more and more doing their work remotely, which is great because everybody should benefit from all of this cultural automation, not just engineers. So I could go on and on about chat. You get a searchable transcript of all of your important decision-making processes. You get a lot of the cross-pollination that you get from an open office while still being able to shut the door and quit out of the chat software. All kinds of good stuff here. I'm going to assume for right now that you're all sold and that you all do have or will have chat software in the near future. So step 2 is to add a robot to your chat. And this is becoming kind of a big deal too. This is the title or the URL of a report from the Gartner Group. And the title is super gibberishy, but here's their main prediction. Far from being toys for nerds, bots will be an important part of just everyday business. And sooner than you think. This is predicting by 2020 that 2/3 of meetings will have some kind of automated assistant involved in them. So writing a bot for your company might actually be a strategic move for you, right? So let's talk about how to make one. There's a number of good frameworks for these. Hubot that GitHub uses and that Gridium was using is open source. This is a framework that you just spin up. It is written in CoffeeScript, which it's an artifact of its time. But you can just write JavaScript in it. Obviously, you can Webpackify it. You can do anything you want to. But I know that everybody in this room probably writes JavaScript all day long. So if you want a break, there's also or err. I haven't figured out how to pronounce this one. This is written in Python, and there's also Lita, which is written in Ruby. Both of these have also been around for a while, almost as long as Hubot has, and all 3 of those have vibrant plugin ecosystems. There's a ton of stuff you can just install into there and turn it on, and then you get automations just readily available to you. Or if you want to dig really deep into the internals of your chatbot and get ultimate control over the UI that you provide, I'm pretty excited about BotKit. And this is what that guy's plugin was written with. That's how we managed to start a private direct message with the person. BotKit makes that pretty straightforward and gives you a lot of control over what you're going to do. Step 3 is to automate something. My advice would be to pick something easy to start with, like maybe ask the bot how long it's been since you've deployed or since you've done a release. It's easiest to start out with just reading information that's readily available instead of writing or causing some sort of possibly destructive action. One thing that you've got to do is build trust. If people won't trust the bot with silly, trivial work, they won't trust it to do serious work either. So start with the silly stuff, turn on the GIF searching thing, turn on the video searching thing, have it tell you a joke, and have it put some graphs up, and then start doing like real OPSI work. All of these bot frameworks will provide a lot of the plumbing for you, so it's real easy to get started. You mainly just write the logic that you need. So here's a couple of examples. This is what a very simple plugin looks like in Hubot. You give it a regular expression that it matches incoming messages against, and then you tell it what to do when you get that. And you can have matching groups in the regular expressions and pull those back out. There's a bunch of stuff here. This is what it looks like in which it turns out these colors are really bad for the screen, so I apologize, but it's Python. I'm guessing there's maybe 1% of you will probably end up writing in Python. I don't know. It's probably not going to be a popular choice. And then this is Lita. This is the Ruby version. All of these have very, very similar looking interfaces. This is what it looks like in BotKit. You'll notice there's this extra line here where you get to choose the context where you're going to reply. So you can limit something to not being available in a direct message or only being available in a direct message. All kinds of good stuff with BotKit. Obviously, these are really trivial examples. This is what the high five source code looks like. I don't know if you could read that.
I can read it perfectly.
It's not.
A lot of shit at the bottom.
Yeah. This is the list of GIFs. Yeah. It's got a very extensive collection. So this isn't as bad as it looks, right? There's a lot of just like data arrays in there. It's about 300 lines. Mostly it's just sort of gluing together a couple of other services. But this is par for the course. This is one of the most complicated integrations that I've worked on, 300 lines. You can do this. And then the very last thing you should do when you automate something is tell me about it. I want to hear your stories. I want to hear what people come up with to automate. This is all really cool stuff. There's a little bit of community around this kind of development, but not a lot, and I really like to see it grow up to be something else. So tell me on Twitter. I'll give you my email address. Just let me know what kinds of things you come up with. I'm really looking forward to it. Thanks. Anybody have any questions? Yeah.
Where do you stop?
Where do you stop?
So we already use like a GitLab, and we use essentially a bot on Mattermost. So we had Rocket Chat before, now we have Mattermost internally. Because our company will let us use Slack externally, but where do you, so like right now, like when we do essentially pushes and merges and all that kind of stuff, it shows up on essentially the GitLab and the Mattermost channel, usually activity, like some project activity.
Right.
Where do you stop? Do you stop at like, oh, you broke the build? Do you keep going and broke the build? Like, what's your experience in that respect?
So the question is for streamers and for the recording is where do you stop? How far do you go? Do you go with like fire hose type notifications? Do you want to continue on to who broke the build? Do you want to like how far past that do you go? And I don't think there's a really good answer for that, right? It's kind of up to the team. The goal is to provide functionality and information that's useful to your team. And so I can't answer that for your team. Maybe they do want to know about every commit that gets pushed to GitLab. Maybe they don't. Maybe they just want to know when a merge happens. But I wouldn't stop at just source control and continuous integration. Like there's more in the pipeline after that you can get a lot of value out of by adding it into the chat room. And even if it's just notifications, like such and such did a deployment. It worked, hooray, right? Nagios is happy. Awesome. Party at my house, right? Train it to order pizza for your team. The sky's the limit, honestly. Beer is good too, yeah. Honestly, there is no endpoint to this. You can keep automating as long as you want to, right? Just like any software is never done, this is never done. There's always more value you can add to your team.
If I summarize your answer,
Yeah, it's cultural. It's all up to the specific team you're talking about. Anybody else? All right, I will yield the floor then. Thank you.
I'm going to take a short break while we switch over to presenters, so make yourself it actually compiles out to files on the side. I actually have a part online that kind of walks through it says, hey, let's start by using the TypeScript out there, but I can see you can use this like you use now. So here's what I using VS Code, right? So imagine this is like VS Code will definitely tie it to all yes. So there is so you can just use if you're already using Gulp, you probably have a source. So you'll want to tell the compiler what folder what source. Wow.
Seems like everything's good. Yeah, might bump some things.
There is a goal that you can add to your side. You're probably going to want to do that early. And then, like you'll do it before you would. And that way your build change will so yeah, I mean, so if I just get better, so you told me that, so step one thing I thought was new and VS Code automatically start trying to,
There's always ways to find yourself.
This all goes through now. That's really good. How to try to do your presentation.
Yeah. And if you find me on there.
Oh, it's like, doesn't make any sense. It's just work. We did a lot of
Audio sampling, not really.
I've done this before. I've done a lot of screencasting, so.
What's that?
So I've done a lot of screencasting, so I know the joys.
I swear, like I get it set up, and then like partway through the Mac just decides that like something changes with the USB throughput. And it's like,
Yeah, just like the drifting, or like the audio drift.
yeah, like right now, what happens? I had to increase the delay of the audio because the video and the audio get the same. One's taking longer than the other.
Yeah.
Process.
What are you using? Do you using Logic or anything like that?
I'm using OBS, Open Broadcast.
Yes.
To like combine the camera, and I'm taking a feed of the HDMI so I can set up a scene.
Yeah.
And if I had like $2,000, that's what I would go buy that just like solves all hits.
Right. Yeah. I'm ready. Yeah.
All right, so let's get started. So please welcome Mitch Lloyd, who will talk to us about static analysis with TSLint.
Thank you. Yeah, there's gonna be a lot more code in this talk, so hopefully we can all hang together, and hopefully there's no big snafus, but we'll see. This is me. My name is Mitch Lloyd. You can find me at these places. This is what I look like. I work at a company called Twitch, and I'm a front-end developer there. So if you've been working with JavaScript on the front end for a few years, I'd love it if you would talk to me, because we are definitely trying to hire more front-end developers. And we're big into TypeScript. So what is static analysis? Linting is a type of static analysis, or something that you need to do static analysis to do well. So it's really just looking at code without running it, which is actually pretty natural for us, right? That's like what we do all the time, all day. Luckily, we don't run code when we look at it. It's been a while since I've read this book, but I know in Snow Crash is like there's some kind of linguistics virus where they could say something to you and your brain would run it, and you would see static. And
I recommend that book in the Diamond Age, which comes out.
oh yeah, I've not read all the Diamond Age. I think I started, but So if there is something I'd like to hack in your brains, maybe it's that this is something that is actually kind of approachable and something that you could actually use in your job or in a side project even, something like that. I think linting and abstract syntax trees, it sounds very complicated. It is very complicated. But there's just a few tools. If you know how to use them, it can actually be pretty simple. So yeah, linting is one thing you can do with static analysis. Obviously, you can do type checking. That's something that we like about TypeScript, right? There's things like code mods and JF shift. If you have a giant code base and you need to migrate from one kind of trivial syntax to another trivial syntax, you can run things like that. Not a lot of frameworks for that in TypeScript that I've been able to find, actually. But you can use TypeScript directly. Things like formatting. I'm really excited about a library called Prettier, which takes your entire code base, ignores all the formatting that you did, turns it into an abstract syntax tree, and then just formats it back out. So it kind of ends all the arguments, because you don't even have control of your formatting anymore. That's only for JavaScript, but there's actually a TypeScript plugin underway to work with Prettier, so I'm pretty excited about that. And then statistics. Like the easiest thing you can imagine that would be static analysis is like, how many lines of code do I have? That's pretty, just like split by a new line and count it up. But then pretty soon you probably want to omit comments because you don't want to penalize people for that. And you can see how you start to fall into this need of some kind of abstract syntax tree. So linting, what is linting? It's basically like a Slack bot that you can put in your code editor. I haven't seen one that will buy Amazon cards yet, but since I work at Twitch and we're owned by Amazon, I think we'd be like way into that if we could get more cards going on. So yeah, the abstract syntax tree. Why would we create one of these? Well, it's free of just sort of like this incidental noise. So in JavaScript, if you use single quotes or double quotes, someone on your team may care, but the code does not care. So it will turn it into a string literal, and it doesn't matter. Optional braces, did you include a semicolon, these sorts of things get filtered out and turn into something that's more pure, more what the language designers are thinking about. It's an easier structure to work with. Obviously, parsing text is kind of a little bit challenging. Organizes it into a big tree so you can kind of traverse it easily. And lastly, you can also add information to the tree. You can't really add information to people's source code, but if you have an abstract syntax tree, you could start to add more information to those nodes to do something later with a compiler, perhaps. So let's look at a linter. TypeScript, actually, in their wiki, has an example of making a linter. So TSLint is what I'm going to be talking about, but this is an example of how you would maybe just make a linter if you just imported TypeScript from NPM and went to town. So the first thing's actually at the bottom, and that is getting a bunch of files just from the file system with Node. Where is it exactly? Oh yeah, read file sync right there. So given these file names, read them into a buffer, and then call ts create source file. And then from there, you've got abstract syntax tree. That's what the source file will be. And then you can run your dlint function on it. And this takes a node. Node is the beginning of a tree. And it has a giant case statement. It goes through and says, oh, does this look right? Does that look right? If not, I'm going to report an error. And that's like mostly the implementation you're going to see later too for TSLint. And then at the end, it just says for each child of that current node, go and run the same thing again. So it's recursive. So that's kind of it in a nutshell. Load up a file, turn it into an abstract syntax tree, and then just run a recursive function that walks through all these nodes in the tree. So it does like a depth first search, or walks in a depth first way through this tree, which is actually pretty natural, because if you think about how we think about JavaScript, or how we must think about JavaScript, maybe it's JavaScript forcing us to think this way, but there's like let, for instance, is block scoped, right? So we're kind of doing a depth first analysis here. If we say, okay, well, A is 1. Okay, now I'm in the context of the if statement, so I can declare another A, 2, and now I'm in this do while block, so I can declare a third A. And if I log those, I'll get 1, 2, 3, 3, 2, 1. This is how we also read code, so it makes sense that that's how these walkers work. So let's look at some TSLint boilerplate really quick, just sort of what a project looks like if you're going to make your own rule. It's not too bad. I've got a tsconfig file to handle the TypeScript, and I'm putting all of that output into the dist directory. I've imported just TSLint and TypeScript, those two things. And I've got some scripts over here to run tests and also to type check this project, or to lint this project itself, which will just come in handy for demoing here today. And of course, I'm sure everyone here does TDD, so you're excited to hear about the tests. But the tests are pretty interesting. They're just like you write examples, and these red squigglies here mean I expect to see those squigglies when I actually run the test. And over here you put what you want it to say. And then you can make examples like this and say, well, this one is going to work, so no squigglies there, please. So it's pretty approachable. You put a config file next to it. That's just like a config file you would put in your own project if you're going to use it. So you've got those two things, the lint examples and the config file. Now, if you want a different config file, you need to make a new directory. So the trade-off here is maybe a lot of files if you have a lot of different kind of config for your rules, but pretty straightforward. So let's run what I have now. I think if everything works, of course. Okay, so it's saying actual things, nothing. I got no actual squigglies. But I did expect to see these green squigglies, and they're not there. Make sure I don't get too far ahead. Yeah, so let's talk about an example. We're going to dive right into making one of these things. So let's say on your team you've got a certain deprecated module. You've got a giant code base, many developers, and they keep using this parse query params module that you know has got like some bugs, but part of your code is relying on these bugs. You really want to get people to move to another thing you made called like parse params or something. So how can we get them to stop using that deprecated module? Seems like a pretty easy case. So quickly, this is I guess this is more of the boilerplate aspect. Every time you make a rule, you're going to import from this abstract rule. You can see examples of this if you go to the TSLint website. I've made a failure string, and you call apply. You call apply with Walker. So Walker is really the thing that you're in charge of creating. And we will implement this deprecated modules Walker, and that's the thing that's going to like report errors for us. Let's see. So, right, now we're sitting here thinking, okay, so I know this is like an example of good, an example of bad, and I've got this rule, and I need to implement something here. How do I even go about beginning to understand what to do? I think one of the biggest tricks is you just take these things, you copy and paste them, and you put them in something called AST Explorer, which is a great website if you've not seen it. It's like JavaScript, TypeScript, handlebars, all kinds of crazy stuff. It'll tell you what the abstract syntax tree is and make it really easy to look at. So if I paste this example in that I know is bad, I can start to look at things and say, well, okay, right here, this is the thing I know is, like, please don't do this. So even though I don't know what these terms are, totally fine. This is called a module specifier. I guess that's what the TypeScript people have decided to call it. And this is all different than JavaScript, by the way. TypeScript has incompatible AST with JavaScript. All the names and things are different. So I can see, okay, so that's a string literal there. And it's the blue thing, the type here is an import declaration. So I've got these two pieces of information. I know there's something called import declaration that comes around somewhere in this tree, and there's also these module specifiers. So, yeah, getting closer. The next thing is looking at what the Walker provides for us. So the base implementation of the Walker just provides all these methods like visit any keyword, visit array types, like tons of methods, just like helper methods. Importantly, they're doing, adding types here, so when your function gets it, it'll know what type it is, which will help you. And then here, just like the other thing we saw, this is the giant case statement. Just goes through each one of these nodes and says, okay, is this an any keyword? Is this an array binding pattern? If so, call the method. I mean, it's just over and over and over and over and over and over. So we can find our import declaration. So there's one of them. So like visit import declaration. That sounds pretty good. So if we could visit that import declaration, we could look at that node. We could find its like once we get that import declaration, if we just say import declaration.module specifier, and we look at the text there, and it's parse query params, like we know that's bad. Like let's go ahead and log that error. So I am not brave enough to try that in front of you, so I will skip to my next step here. All right, so here is the wonderful implementation with lots of comments. So yeah, just like I showed, I use the visit module, visit import declaration method that TSLint provides me. Just like I said, I looked at that node and I went up and said, okay, what's your, look at the module specifier, and actually this is a little bit interesting. So the first thing we have to do is say, yes, we understand that this module specifier is a string literal. ECMAScript, when you do import statements, that must be a string literal. You can't use like string interpolation or anything dynamic there. That's a rule. But TypeScript has chosen to just make it an expression so they can do better error handling or something like that. It's interesting. But yeah, so once we get that import string, or once we get that node, and we can tell TypeScript, hey, this is definitely a string literal. I know it because that's the spec. Then we can say, okay, is it parse query params? And if it is, then we can call this method to add a failure. So node get start and node get width, this all determines where those squigglies exactly appear. So right now we've got all the squigglies under all the stuff. And after I did this, I realized like maybe it'd be better to just put the squigglies under this part here, because I don't know, that's a lot of squigglies. Like maybe we could be more direct and say, hey, it's just that string. So if we want to do something like that, instead of using the import declaration, we would want to just use this module specifier here. So if we change this to, if my keyboard works. Well, I don't know what's going on. Okay. So if we use module specifier there, module specifier there, and we run our tests, well, you can see that we just get the squigglies under the module specifier part. So that is the basic idea. And I guess I never showed that it should pass. Yeah, our first passing test. That's great. Maybe a little more interesting if we can actually see it at work. So I added a little demo application here. Here's my utility, and I'm importing query params from parse query params, and it says, please use query params instead. This is deprecated. And if I change this to, I think it's like just here, then it goes away. So it's working, like actually in our code editor. Amazing. So that one's actually pretty simple because module declarations are pretty simple. They're right at the top. I want to show one other thing that's maybe more TypeScript specific. So let's say in this case that we want to enforce a custom location abstraction that you have in your code base. I feel like this comes up a lot because we have test runners that expect you not to say like location equals google.com. You will reload your entire page. Opening windows, these sorts of things are often good to hide behind some abstraction. Anytime you have a global in the browser that's difficult to control like that. So we'll say we want to enforce that people use our abstraction, they don't use the actual global location object. So let's hop to the next step. It's like extra tiny on my screen. Okay, so I've got a test here. This is a little more complicated. There's all kinds of different ways you could call location, and there's obviously limits here, but so just calling location, right? If you're in a browser, that's going to work. If you call it with a method on it, that's bad. Please don't do that. You can use this fancy destructuring thing. You can call it on window. You could call it inside of a function, and then here's some things that are okay. It's okay to have like your own property called location. It's okay to assign a property called location. It's okay to build an object that has a property called location. So this is kind of the cases we're dealing with here. And obviously you can start to think like handling all these cases could be pretty complex. There's one thing that TypeScript gives us though that we don't have in things like JSLint and ESLint, and that is the ability to actually look at the TypeScript program and use the type checker itself. So for this one, this is what I want. we've got a slightly different rule that we're going to import from. It's called a typed rule. And instead of just the previous apply method, we have something that's called apply with program. Program here is nothing TSLint specific. This is a TS program. So this is a TypeScript thing that we'll be using directly. And just actually same method, apply with walker. And our walker is a program-aware rule walker. So it's slightly different, but everything else, the structure should be exactly the same. So let's look at what a solution for this might look like. So again, let's see. If we look at these examples, let me get some of them here. All right, let's just paste some of these in the abstract AST Explorer. Oh, that didn't work. Give me another one. All right, so we look at these things. We can just click on locations. Like, what are these things? Well, here we see it's an identifier. Here again, it's an identifier. And spoiler alert, basically any one of these places we look at what location is, it will be an identifier, which is really just something that just tells us like what something is named in our system. But it looks like we're probably going to need to look at the identifiers. Then we kind of need to think about, okay, so what's different about something like foo.location? This is like an expression statement. Actually, okay, so I'm getting a little bit ahead because in this case, we've got a hack. We're just going to use the type checker. Because if you go to TypeScript and you just add something like location here, we should be able to see. Yeah, so TypeScript understands that this is capital location, like this is the global location. Let's go this one. All right, so let's look at the implementation here. So to start, I used visit identifier. Again, if you look through that giant list of methods that's available to you, you can find this there. And then we just look and make sure we don't really do anything unless we actually see that the text is location. So already we're like filtering our scope down quite a bit there. Then we get the type checker. And this is just the TypeScript's type checker. This is not a TSLint thing. So if you are going to compile TypeScript files on your own, you would also use things like this. We get the type at a location, and then we convert that type into a string. We say, all right, if it's location, then add this failure. So that's pretty straightforward, actually. We don't really need to dig around the nodes in the tree very much and do that sort of thing. If we run our tests, test passed, that's great. If we run our linter, we can see, I've got two errors in my demo project. One saying about the custom location, one talking about the query params. That is all good. But there is one problem here. We do not have the squiggly here, and periodically I need to like reload because things tend to get sort of cached. But yeah, definitely no squiggles there. So this is because the plugin I'm using does not actually support rules that are type checked, which is unfortunate. There is something underway. I've looked in the last couple days. It seems like there's a way forward, and they'll be able to do this hopefully pretty soon, but as of now, you cannot. And just for interest's sake, I did go through and go through the trouble of making the rule that does work. It's a little more hairy, probably more than I'd want to talk about in a very brief demo, but I think this can start to give you a flavor of why you really want to have nice tests for this sort of thing, because it is a lot of Boolean logic, and yeah, you'll definitely sit there saying, okay, now if it's not this, but if its parent is that, it's like you totally need tests. And you totally need to make these helper functions that do things to abstract these things out. So you can just say, okay, so if it's a property, or wait, is it actually the window.location identifier? That's like an idea. And then it can become a little more readable. I could probably go even further with this one. But again, if it's the location, if the text says location, we can say, okay, if it's a property, then we're okay, that's cool. But wait, if it's like window.location identifier, we're not okay. And then finally, we actually will allow people to make new objects with location, so allows property assignment. So this kind of thing can get a little bit hairy, but it can also be kind of fun. The tests are pretty easy to write, and this stuff can be some work, but if you've got a big code base, lots of developers, you can have a lot of leverage and really automate some of that stuff that you might be nagging people about in PRs. It's like if you can catch it with a linter, it's so much better than if you have to nag people in PRs about doing things. Yeah. So things I didn't cover. There's configs, like our deprecated modules rule is a little bit ridiculous because just to have a rule for one file is crazy. You could just pass in strings and say all these modules are deprecated and maybe an object. Please use these modules instead, that sort of thing. Fixes, you can have it automatically fix things for you. This is not very useful in practice when you have big fixes. Like semicolon insertion is the classic case. If you're missing a semicolon, just add it. But anything beyond that gets pretty crazy and hard to do well. So yeah, there are limits to this kind of automation. This is really good for the 80% case, right, where you want to get that fast feedback in your browser. But like people are always going to be able to work around your syntax rules in a dynamic language. So yeah, location, that wouldn't work. Locate.shun would also break the rule. So you do have to be careful with these dynamic cases, but you can often catch quite a bit, like when people assign a function to something they call it. You can track that, and I have done that, and it has worked. Yeah, so ASTs. ASTs are kind of complicated, esoteric sounding things. They've got weird names for all the bits and parts. It seems kind of complicated. But luckily, you don't really need to learn that stuff. Like you don't need to know cold looking at something, oh, this is this kind of an expression, it's kind of literal. You can just use the AST Explorer, that's what everyone does, and just figure out what those nodes are in the tree and usually backtrack from there. Linting is great. It's a great thing you can do with ASTs. Things like Prettier, which I talked about earlier, are great things you can do with ASTs to get people to stop arguing about formatting. Code mods, also pretty critical if you're working with ASTs. So that's it. Hopefully there's something that you guys found there that makes you think making TypeScript TSLint rules is not very intimidating. Obviously this applies to things like ESLint as well if you're working in JavaScript more. But hopefully you can find some kind of use case in your day-to-day life to make your life better through some automation with ASTs. Cool. An immediate question.
I was going to ask you a question. Do you have any rules, custom rules that are published that says share? Like that module deprecation one was really handy.
Yeah. Well, this is on my GitHub. You can find that. You can find it there. I pushed that recently. The best. So the problem with some of these rules is the biggest collection of these rules is for Microsoft, and I mean I look at those for examples. I mean, there's many rules already written. Also, within just TSLint itself, there's many rules. And like to find this stuff, like, it's like something to do with imports. Search for imports. Find rules that do things with imports, and you can kind of figure out, oh, okay.
Could you create a rule that, say on a deprecation one, took an input of the name of the module that was deprecated, and then it would create a rule deprecating that module by itself?
Oh, sure. That seems like a pretty obvious one. I have a feeling. I mean, yeah, don't go write a bunch of rules that are already like out there.
So you mean
there are tons and tons of rules like pre-made for you. There's probably better documentation that's going to GitHub, but I mean, like these. Let's see. Import blacklist rule. There you go. That's probably pretty good for start. And then Microsoft. There's like a Microsoft one that has like, I don't know, almost 100 rules in it, I think. Microsoft contrib. I have this horrible bug on my machine. I don't know if anyone else has that. But here again, you will find many rules somewhere. Yeah. They also have many rules. Their testing is a little bit different. I think they started earlier and this testing setup wasn't there, and they just have TypeScript tests, which can be kind of nice sometimes. Less verbose than making a bunch of files, but yeah, maybe not the best example of modern testing, but many rules to choose from there.
So we use essentially, we create a common Git repo for TSLint rules.
Yeah.
We actually can use the extends comment in the TSLint config, which is super helpful.
Yeah.
What you're talking about. But one question I had was, when you create those rules, you're creating them in kind of a root directory of the project. That's essentially something that you assign as true. Have you used those essentially as a dependency in your projects, and how to include them as dependencies?
Yeah, let's see. So I'm not sure if this is the greatest example, but it might work just fine. So basically, so let's say you didn't want to import it, or you want to have it be a separate package and import it. I mean,
We usually put a package JSON like dependency that says, some scope / our custom rules, and then
Yeah.
put that in as the extends.
yeah, I'd have to look up the exact syntax on TSLint for importing a plugin. I mean, I think there's just like a plugins thing that tells you it's there. But beyond that, everything else here is like just a TSLint config. So here I'm not extending anything, but obviously if you had a configuration set, you could extend some kind of like, oh, this is a base set of rules. I think it's probably just plugins, and you would name your plugin here, and then turn your rules on and off and what severity level. Here I added my rules directory because I had it locally in this project. So if you don't want to import them, if you want to have them local, that's the way to do it. Cool. All right, thank you.